Rotary friction welding is a technique of solid-state pressure welding that employs only friction heat and pressure generated by strong mechanical force. One side of the material is fastened and fixed using a friction welding machine, while the other side is attached to the rotary chuck and rotates to advance. When the friction surfaces of the two materials are heated to appropriate temperature of approximately 1,200 degrees Celsius, the rotation is immediately stopped, pressure is applied, and weld bead processing is used to complete the bonding. It is possible to reduce production cost through processing cost and time reduction by drastically reducing processing time in comparison to the standard processing process. As the core technology of AFW, it is applicable to a variety of materials, including dissimilar and non-ferrous materials, boasting superior weld surface strength compared to the base metal. Friction stir welding is a method of bonding by generating frictional heat with a special tool and moving along the material's surface. When a non-consumable tool having a probe is inserted into the joint surface while rotating at high speed, heat is generated by the friction between the tool and the workpiece. This frictional heat softens the material around the tool. Materials on both sides of the joint are joined by advancing the tool while stirring, and removing weld bead completes the welding. It is a method of solid-state welding that employs frictional heat. It has excellent strength as defects such as pores or cracks does not occur, which are common in fusion welding. It is the best bonding method for joining non-ferrous metals and composite metals with a low melting point. FSW does not require the use of heat source generators, welding rods, fillers, atmospheric gases, etc. Unlike conventional fusion welding, no hazardous gas or harmful rays are generated during bonding, making it possible to establish an eco-friendly working environment. In addition, it reduces production costs by enabling the standardization and automation of quality that is independent of the operator's skill or function. Friction welding is a method of bonding where high-speed vibrations are generated with an object via linear reciprocating motion. Two linearly vibrating materials vibrate at high speed when they come in contact with one another. At this point, the frictional heat creates an appropriate temperature. The two materials are bonded, and the welding process is completed through the melting point processing. In contrast to RFW, which employs rotation to press weld at high temperatures, LFW, which uses heat generated by linear vibration motion to perform pressure welding with high compressive force, reduces processing time and production cost. In contrast to RFW, the material's cross-section doesn't need to be round or tubular, making it ideal for sheet materials since it can process both circular and rectangular shapes.